Have you ever stopped to wonder how does AI really think? Not just spitting out words, but what's actually happening behind the scenes. We hear about AI all the time, but most people assume it's just a supercharged search engine, grabbing and summarizing information. The truth is there's something much deeper going on, something that might even remind you of how we think. AI doesn't just repeat information, it recognizes patterns, makes connections, and generates responses that feel surprisingly human. It's almost like it's understanding. But does that mean it's actually thinking, or is it just a clever illusion?
That's exactly what I've spent the past month breaking this down into the clearest, most easy to understand explanation possible. By the end, you won't just understand how AI works, you'll see how its intelligence compares to ours in a way that finally makes sense. Let's get into it.
Before we can answer whether AI thinks, we need to understand how it processes language. It actually doesn't perceive words like we do. Instead, it breaks down our messy human communication into something more mathematical, more precise. In fact, human language is beautifully chaotic. Words change depending on context, new words appear all the time, and some words are so rare that if AI treated them as single units, it wouldn't have enough examples to learn from. Because of these limitations, AI analyzes language differently than humans. It breaks text into smaller pieces called tokens that could be full words, parts of words, or even single characters. For example, take the phrase unbreakable wall. After tokenization, it would be split into unbreakable wall and exclamation mark. This way, even if AI encounters a completely new word, it can still understand it by analyzing its smaller parts. With tokens, AI can now break language into more manageable pieces, but recognizing words is only half the battle. The real key happens when it strings them together to form a response that actually makes sense.
So, how does AI do that? Well, it plays what I like to call the prediction game.
Imagine someone says salt and your brain instantly thinks pepper. You don't have to stop and analyze every possible option, you just know it. That's because over time you've learned that salt and pepper often go together. AI works in a similar way, it recognizes which words tend to appear together based on patterns it has seen before, but instead of personal experience, it learns from massive amounts of text. For example, if AI is trying to complete the phrase the sky is, it might calculate probabilities for the possible next tokens or words like this: blue at 85%, cloudy at 10%, and falling at only 1%. Since blue is the most probable choice, AI selects it, but this process doesn't just happen once. In fact, it repeats for every single token in the response and at an incredible speed. AI starts by predicting the first token, then based on what it has already generated, it predicts the next one, then the next one, and so on. This way, each new token is not chosen randomly, it depends on what came before. That's how AI builds responses that flow naturally and make sense. In essence, this continuous process of prediction is what allows it to generate full, meaningful responses. But there's a catch. If AI always picked the most probable token, its responses would be predictable and robotic. Just imagine if every time you ask, "How are you?" it always replied, "I'm fine." It would feel unnatural. So, to make responses more varied and human-like, AI introduces a bit of randomness. Sometimes it chooses a slightly less probable token, which makes its responses more dynamic and creative. But how does AI figure out these probabilities in the first place? How does it know that in the phrase "the sky is," the token blue is a more likely next word than falling? To make these predictions, AI needs more than just a list of tokens. It needs a system capable of processing text, recognizing patterns, and understanding context.
This is where something remarkable comes in. A system inspired by the most complex thing we know in the universe: your brain.
Right now, as you're watching this video, billions of tiny cells in your brain called neurons are constantly firing signals. Every thought, every sound, every image you recognize happens because these neurons are passing information to each other. But they're not working alone. Each neuron is connected to thousands of others, forming an incredible complex network. This is how we learn. When you see a cat for the first time, your brain starts building a pattern of connections, and the more cats you see, the stronger that pattern gets. Eventually, you don't even have to think about it, you just know it's a cat. Now, imagine we could build something similar, a system that doesn't just store information, but actually recognizes patterns and makes decisions based on them. Well, that's exactly the idea behind the technology that powers so much of modern AI: neural networks. These networks use artificial neurons, kind of like the ones in our brains that are all connected and send signals to each other. But instead of the chemical signals our brains use, these artificial neurons use math to share information and adjust their connections. This is how AI learns, how it recognizes things, makes predictions, and generates responses that seem remarkably intelligent. But what's the invisible process happening inside the neural network that makes this actually work? How does it take raw information and transform it into something meaningful?
To answer that, we need to go even deeper and take a peek inside the core engines of neural network, its layers.
Think of a neural network as a team of specialists working together. Information flows through them in stages, getting refined at each step. These stages are called layers, and each one has a specific job, transforming the information before passing it along to the next layer. This step-by-step process is key because it's what allows AI to extract meaning from raw text instead of just seeing it as random symbols. Every time AI generates a response, the tokens we talked about earlier travel through multiple layers, each layer adding another level of understanding, bit by bit, until AI can predict the next token or word in a way that actually makes sense. So what do these layers actually do? Let's break it down. First, we have the input layer. This is where everything starts. AI receives the tokens from the text, but at this stage it doesn't really understand them yet. It just knows which tokens it has received. Next, where the core processing happens, the hidden layers. These layers take the raw tokens and gradually extract meaning from them, step by step. Think of each hidden layer as an expert in a factory, each focusing on a different part of the job and processing information before passing it along to the next expert. Early hidden layers focus on simple patterns. They might start to notice that certain words often appear together, like the example of thinking the next word after salt and. These early layers might begin to recognize that pepper is a likely next choice. Middle hidden layers start understanding context. Words can have different meanings depending on how they're used. For example, bank could refer to a financial institution or the side of a river. These layers figure out the correct meaning based on the surrounding words. Deeper hidden layers handle more complex ideas like metaphors, sarcasm, or even poetry. These layers help AI understand the difference between breaking the ice as a way to start a conversation versus literally smashing ice. Each hidden layer refines the information a little more before passing it forward, like a team of experts analyzing a problem from different angles. And finally, after all this processing, we reach the output layer. Here, AI makes its final decision on which word or token comes next. Remember our example of the sky is? At this stage, after considering the input, context, and likely words, AI decides that blue is the best choice rather than falling. But these layers and the way they connect are already set up when you use AI. They've already been through a process of refine and adjustment to work this way.
And that raises a big question. If these layers already know what to do, how did AI learn to adjustment in the first place?
Before AI can generate responses, it has to be trained, a process where it learns from massive amounts of text. This is how the layers we talked about earlier get fine-tuned to recognize patterns, relationships, and context between words. Think of it like teaching a child to read. At first, they struggle with letter shapes, then move on to simple words and eventually full sentences. Over time, they recognize meaning instantly instead of having to sound out every letter. AI follows a similar learning process, except it does this on a massive scale, processing billions of sentences instead of just a few books. But AI isn't just trained on any text, it matters what kind of text it learns from. If the training data is messy, full of mistakes, or biased, AI won't fix those problems. Instead, it will pick them up and repeat them. Just imagine trying to learn a language from a book full of typos and made up words. You might still recognize some patterns, but your understanding would be all mixed up. That's why choosing the right training data is so important. It helps AI give better, more accurate, and safer responses. So, how does training actually work? At the start, AI doesn't know anything. Its neural connections are completely random, like a blank slate. Then it's fed huge amounts of text and it starts looking for patterns, figuring out which words tend to appear together, how sentences are structured, and what phrases make sense. In this process, AI tries to predict the next word based on what it has analyzed so far, but how does it know if it's getting things right? The answer is simpler than you might think. It learns from its mistakes. Whenever AI makes a prediction, it measures how far off its response was from the objective. If it was close, it adjusts its connections slightly, but if it was way off, it makes a bigger adjustment. Then it tries again and again and again millions of times, fine-tuning itself until it gets really good at making accurate predictions. This process of trial and error, constantly measuring and adjusting, is what allows AI to refine its understanding and become more accurate over time. And there are different ways to train AI, but this process happens in all training methods in its own way. It's the core principle. For example, one of the most common is supervised learning. In this method, AI isn't just giving text, it's also giving the correct answers. It's like giving a student a worksheet with the answer key and showing them exactly where they went wrong each time they make a mistake. In a similar way, in reinforcement learning, AI is rewarded for making good decisions and penalized for bad ones, kind of like training a dog with treats. Good predictions get a treat, while bad predictions get a no. On the other hand, unsupervised learning lets AI find patterns in data without being told the right answers. It's like handing someone a huge pile of puzzle pieces and letting them figure out how they fit together on their own. They have to find the patterns themselves. This trial and error method is very similar to how humans learn, but AI does it at an extreme speed. Instead of taking years to master language, it can process and refine its understanding in a fraction of the time. Each method helps AI get better in different ways, but here's something most people don't realize. Once training is finished, AI stops learning completely. When you use AI, it isn't still improving, it's just applying what it already learned during training. Its neural connections are set and won't change no matter how many conversations it has. It won't grow or update. That means if AI was trained before a major event happened, it won't know about it. It can't learn from your conversations, remember past discussions, or update its knowledge on its own. To learn new things, it has to be trained again with new data.
And that leads us to another big limitation: AI's memory is limited.
AI can process tons of information, but it has a limit to how much it can keep in mind during a conversation. This limit is called the context window, which is basically the maximum number of tokens it can remember at any given time. For example, ChatGPT 4.0 might remember around 8,000 tokens, which is roughly 16 pages of text. That sounds like a lot, but think about how long some conversations can get. Once that limit is reached, it starts forgetting the earliest parts of the conversation to make room for new information. Think of it like trying to write on a whiteboard with limited space. As soon as the board is full, you have to erase the oldest notes to add new ones. So if you reminded AI of something at the start of a long conversation, it might forget that detail by the end. Now imagine if you had this kind of memory. By the time you got to this point in the video, you'd have completely forgotten how it even started. No build up, no context, just isolated information with no connection to what came before. It would be pretty confusing, right? That's the reality for AI. While we humans hold on to memories, emotions, and experiences for years, AI's memory is temporary and constantly being replaced. It's like a goldfish with a calculator, brilliant at solving problems, but with no real sense of history. However, researchers are now experimenting with long-term memory, which would allow AI to recall details across different interactions. While this doesn't mean AI would have memory like a human, it could make conversations feel more personal and consistent over time.
But despite these memory limitations, AI's capabilities extend far beyond just processing text. In fact, it has a lot of different skills.
So far, we've been talking a lot about how AI processes text, but the cool thing is, these same basic principles apply to a lot of other tasks too. It's not just about words, whether it's analyzing images, generating art, or even playing chess, AI is still using similar pattern recognition techniques. It's all about finding the connections and adapting them to different kinds of data. Let's take image recognition as an example. Instead of breaking down text into tokens, AI breaks images into small pieces like tiny squares called pixels or even shapes. Just like it learns that salt usually goes with pepper, it learns that certain shapes and colors often appear together to form objects. Let's say it sees a round shape above a long vertical line. AI might recognize that pattern as a tree. Now, what about image generation? It's kind of the reverse of recognition. AI starts with random patterns, basically noise, and gradually refines them based on what it learned during training. Think of it like sculpting a statue from a block of marble. At first, there's no shape, just a rough, noisy block of pixels. But step by step, AI chisels away, figuring out where things like eyes, nose, or mouth go if it's making a face. Then it fine-tunes things like skin tone, shadows, and expressions. It's like slowly building a picture from scratch, adding layers of detail along the way. And even when AI plays games or solves problems, it's still using the same core idea of recognizing patterns and calculating probabilities. So whether it's predicting the next word in a sentence or the next move in a chess game, AI is always asking itself, based on what I've seen before, what's most likely to work here? AI can now handle so many different tasks, from writing to drawing to playing games. It's pretty impressive, right?
But at this point, you might be wondering, how does this compare to how we, as humans, think? Are we really that similar?
It's easy to look at everything AI can do, recognizing patterns, making predictions, generating clever responses, and think, wow, it's just like a human brain. But if we dig a little deeper, we'll find some huge differences. Differences that make us, you and me, uniquely human. Think about the last time you read a book that truly moved you. Maybe it made you laugh, cry, or left you staring at the ceiling, lost in thought. You didn't just see words on a page, you felt them. You connected with the characters, imagined the world they lived in, and understood the deeper meaning behind the story. AI doesn't do any of that, it doesn't care about the plot, it isn't moved by the emotions, and it won't sit there thinking about the story long after it ends. AI is just predicting words like a very advanced autocomplete. And the way we learn, that's completely different too. When you were a kid, maybe you touched a hot stove and instantly you learned a lesson, not just with your brain, but with your whole being. The pain, the shock, the way you yanked your hand away. That experience became a part of you, shaping how you move through the world. AI doesn't learn like that, it doesn't experience things, it can't feel the heat, it can't suffer the pain or truly comprehend the lesson. It only learns from patterns in the numbers it has seen before. And perhaps the biggest difference of all, humans have consciousness, we have intent. When you create something, a song, a poem, a painting, you put something of yourself into it. Your emotions, your memories, your struggles. That song might be filled with the heartbreak of a love lost. That poem might echo with the longing for a home left behind. That painting might capture the joy of a moment you never want to forget. And AI can do these things too, but it doesn't feel a thing. It has no passion, no heartbreak, no dreams. It's like a piano playing itself. Impressive, sure, but there's no musician behind the keys. And that's also why AI sometimes gets things wrong, sometimes wildly wrong. It doesn't have judgment, it doesn't think whether something is right or wrong, fair or unfair, it simply mirrors what it has seen before. If it repeats biases or controversial ideas, it's not because it believes anything, it's just reflecting the patterns in its training data like a mirror that shows everything without understanding what it's showing. But here's the strange part. Despite lacking emotions, consciousness, or intent, AI can still hold conversations, solve problems, and even create things. It follows patterns, yet its responses can feel remarkably human. So, what do we make of that?
We've reached the moment of truth. Does AI think?
Well, that depends on what you mean by thinking. If thinking is about recognizing patterns and making predictions, then yes, AI thinks in its own way. But if thinking means understanding, reasoning, and being self aware, then no, AI doesn't actually think. AI is incredibly powerful, no doubt about that, but it doesn't know what it's saying, it doesn't choose its responses, and it doesn't understand the meaning behind its words. At its core, it's still just a highly advanced prediction machine. Think of it like a car. It can take you somewhere faster, but it still needs a human to decide where to go and why. The car doesn't choose the destination, the person does. AI is the same way. It can assist, create, and generate ideas, but it's not thinking for itself. So, as AI continues to evolve, which it will, it's important to be clear about one thing. Its way of thinking is fundamentally different from how we do, and understanding this difference is the key to being able to use AI wisely.
That's my take. AI doesn't think. But hey, that's just my opinion, and now I want to know yours. Does AI really think? Let me know your thoughts in the comments. I'm TechMora, and if you're excited about diving deeper into AI and technology, make sure to follow. I'll be breaking down tech insights in a way that's easy for everyone to understand. If you reached to this part, I would really like to thank you because this video took me a lot of time and effort to make, and I just hope you really enjoyed it and found it useful. If you did, I would really appreciate it if you left a like and share it to someone that might find it useful as well. With nothing more to say, just thanks for watching, and I hope I see you next time.